Hey class, we're going to continue on with Chapter 2 about matter and change. If you noticed in the last lesson, we covered Section 2.1. This lesson, we're actually going to skip to Section 4. So make sure you turn to Section 4 in your notes in order to be at the proper place to take them. So let's go ahead and get started. This section is all going to be about chemical and physical changes. The opening question is, what happened to the match? Specifically in this lesson, we're going to learn whether burning a match is chemical or physical. Let's start off with physical changes. During a physical change, some properties of the material change, but the composition of the material does not. So what that means is the composition is the makeup. What it's made up of never changes. The substance is going to stay the same, but properties like the shape or its mass might differ. Here's a picture of gallium. Gallium has a melting point of about 30 degrees Celsius. In fact, usually it's going to be a solid at room temperature, but as soon as you put it in your hand, the heat from your hand or your body causes gallium to melt. So it's awesome because when you put it in your hand, it melts, and then when it's just in regular room temperature, it actually solidifies back into a solid. The shape of the sample of gallium changed because it started to flow like a liquid, but the composition did not. It was still gallium. So melting is considered a physical change. In fact, any changes of state are physical. So change in state. Examples of change in state are going to be melting, freezing, vaporization, condensation, sublimation, and deposition. If you've taken integrated science, we went over these 6 terms, but let's just go back through them to make sure we understand what they mean. So whenever you melt something, this is where things are going to be going from a solid into a liquid. Freezing is going to be the opposite, liquid into a solid. Vaporization is where things go from a liquid into a gas, whereas condensation is the opposite, gas into a liquid. You can often tell this whenever you have liquid on the side of a very cool glass, the condensate on the outside. Sublimation is going to be from a solid straight into a gas like dry ice, and deposition is going to be a gas that goes straight to a solid, such as when you see frost on your car in the winter. These words, boil, freeze, melt, condense, are all going to be physical changes. Words like break, split, grind, cut, and crush are also words that you can use to describe a physical change. Here's an example of charcoal. Charcoal can be broken into smaller pieces, and this is considered a physical change. The substances that are there before the change are the same that are there after the change. The only thing that is different is the charcoal's not as big. Again, during a physical change, the composition never, ever changes. How can you classify physical changes? Physical changes can be classified as either reversible or irreversible. So reversible just means you can undo it. So can undo. Irreversible means you can't undo. Melting is a good example of reversible physical change because you can undo melting by freezing something again. For example, with the gallium, if you melt it, you can just let it cool and it turns back into a solid. All physical changes, in fact, are going to be reversible. So all of those 6 that I listed, melting, freezing, vaporization, condensation, sublimation, and deposition. Cutting hair, filing nails, cracking an egg, even breaking a glass are all irreversible because you can never put them back how they used to be. Here's our first checkpoint question. Water boils and becomes water vapor. So water is typically going to be a liquid. Water vapor is a gas. This is just change in state. So any change in state, remember, are going to be reversible. Moving on to chemical changes, we're going to learn what happens during a chemical change. Well, during a chemical change, the composition always changes. In other words, you always create a new substance. We like to use words like burn, rot, rust, decompose, ferment, explode, and corrode to signify that a chemical change has taken place. Here we're going to bring back the charcoal. Charcoal can be heated and burned, and a chemical change has taken place. The reason is charcoal reacts with the air to form completely new substances such as carbon dioxide, water vapor, and even ash. Sometimes a chemical change is usually called a chemical reaction. This is because one or more substances is changed into one or more new substances. The key word there is that you created something new. Now, with chemical reactions, two important terms to understand are reactant and product. Reactant are things that you started out with. Products are the things that are produced, or in other words, what you ended with. Chemical reactions are usually written with the reactants on the left side of the arrow. The arrow signifies that a change happened, so this is a chem change. And then products, or what you got from the reaction, are on the right side of the arrow. In the example that we gave you with burning charcoal, carbon and oxygen are usually the main ingredients, and that carbon actually comes from charcoal. So that's carbon plus oxygen, and this usually creates carbon dioxide, which is CO2. Notice my reactants are on the left and my main product, is on the right. Here's another checkpoint question. What is always true of a chemical change that is never true of a physical change? If you're going to answer this, what is always true of a chemical is the composition always changes in a chemical change, never in a physical change. It all has to do with the makeup, the composition. Now that we've kind of learned what chemical changes are, how do we recognize if a chemical change has taken place? In other words, what are the 4 possible clues that a chemical change has taken place? Possible clues, notice this word is possible, can be things like a transfer of energy, a change in color, a production of a gas, or a formation of a precipitate. Every chemical change usually involves a transfer of energy. For example, energy that's in gas is transferred to food to allow the food to be cooked. Methane is a natural gas. It combines with oxygen in the air, and the energy that it gives off is given off in either the form of heat or light. Whenever light is produced or you feel some kind of heat coming off, that means energy is being transferred. Some of this energy is transferred to the food, and so therefore allows it to be cooked. Again, this energy causes chemical changes to take place within the food, has to do with proteins, so that's biology, and the food changes color. Typically, if you're cooking meat, it starts off as pink, and as it undergoes a chemical change, it turns brown. So that turning brown is another example of a physical change because there's a change in color. The other 2 clues can be observed if you're cleaning a bathtub. For example, if you have a ring of soap scum that formed on the bathtub, this is usually an example of a precipitate. And you might be like, well, what is a precipitate? A precipitate is a solid that forms and settles out of a liquid mixture. This is typically when you mix two liquids together and you form a solid. Some bathroom cleaners that you can use to remove soap scum actually bubble when you spray them on the scum. These bubbles are gas being produced and released, and this is another example of a chemical change. Now, if you observe a clue to a chemical change, you cannot be certain that a chemical change has taken place. The reason for this is because the clue may be a result for a physical change as well. For example, energy is always transferred whenever matter changes from one state to another. So what I mean by that is melting to freezing is going to be a change in energy, but that's physical. Bubbles form when you boil water, but if you boil water, that's just going from a liquid to a gas. That's still physical. Another example is a color change. You can paint a brick, but it's still a brick. So color change does not always indicate chemical. The only way to be certain is to test the composition. So I'm going to go ahead and start that. The only way to be certain is test the composition before and after. Now back to our question at the very beginning of this lesson. Are the changes that happen to a burning match chemical or physical changes, and how do you know? If you said chemical, you are correct. How do you know? There are several things you could have said. You could have said the composition changes. It's no longer wood that is there, it turned into ash. Another example is a transfer of energy. You guys can see the light that's produced and you can feel the heat. Another clue is you see a color change. The wood that was brown has now turned to be black. How can you determine for sure that a chemical change has taken place? The only way is to test the substance before and after the change. Or test the, let's say, composition of the substance. Without ado, we're going to go and talk about conservation of mass. So how are the mass of the reactants and the mass of the products in chemical reactions related? During any chemical reaction, the mass of the products is always going to equal the mass of the reactants. What that means is if you started with 18 grams for your reactants, your products also should be 18 grams. For example, when wood burns, substances in the wood usually combine with oxygen from the air. As it burns, matter is going to be reduced to a small pile of ashes. And typically people are like, well, there was a reduction in the amount of matter. I've lost mass. But appearances can be deceiving. Two products of burning wood are carbon dioxide gas, which is CO2, and water vapor. Water vapor is just H2O in gas form. These are released into the air. If we were able to capture these gases, we would see that the amount of matter is unchanged. So whenever you're doing experiments like this, you should take careful measurements to show the total mass equals the total of the reactants equals the total mass of the products. Mass always holds constant for physical changes. So typically, when 10 grams of ice melts, 10 grams of liquid water is going to be produced. So for any reaction, whether it's physical or chemical, you cannot destroy matter. Scientific law reflects these observations as the law of conservation of mass, which states in any physical or chemical change, mass is conserved. Another way you can say it is mass is neither created nor destroyed. Here's another example of the law of conservation of mass where you can observe it. Here they have two chemicals. The starting mass is 43.43 grams. When they go to mix it, here they mixed it into one vial, we see a color change to indicate a chemical change has taken place. When we measure the mass again, it's 43.43 grams. The product and the reactant's masses are equal. And you're going to see that there's not a decrease because none of these products are gases. So it's you can easily keep that mass in one location. So to what changes does the law of conservation of mass apply? It applies to one, both physical and to chemical. So both physical and chemical changes. And that is the end of 2.4. If you have any questions, let me know, and I hope you guys have a great day.